Welcome back. Today we're going to use our skills that we learn to solve systems of equations in two variables, and we're going to use those skills to solve word problems in two variables. So what we're going to do today is I'm going to ask you to identify your variables, write two equations using those variables, and then we're going to solve the system algebraically to answer the question. So we want to avoid the temptation with word problems to jump right into trying to find the answer. Really, our goal is to find two different equations, find a system of equations. All our word problems are going to have two unknowns, and in order to solve a problem with two unknowns, we need two unique independent equations. And that's what we're going to do in these particular problems. So let us begin with our first problem. The sum of two numbers is 5. The larger number exceeds twice the smaller number by 14. Find the larger and smaller numbers. Well, we're going to identify our variables. Our variables, we may as well make them easy. We'll make L equals the larger number, and we'll let S equal the smaller number. And the sum of those two numbers is 5. Well, there's our first equation. The large number plus the small number equals 5. And the larger number exceeds twice the smaller by 14. That's our second equation. So the larger number is equal to twice the smaller, 2s, plus 14. So here we have our two unique independent equations, and we can go ahead and solve. Since we already know what L is 2s plus 14, we can go ahead and substitute 2s plus 14 into the other equation for L. So we end up with 2s plus 14, or L, plus s equals 5. 3s plus 14 equals 5. We subtract 14 from both sides. We get 3s equals negative 9. Divide by 3, and s equals negative 3. So we know our smaller number is negative 3. We want to solve for the larger number, so we can put that into either equation. Might as well put it into the first one because the numbers are smaller. So we get L minus 3 equals 5. We add 3 to both sides, and L equals 8. So our small number is negative 3, and our large number is 8. So we could answer the question, I guess, and we'd say negative 3 is the small, and 8 is the large number. Let's go on to sample problem number 2. Alex's cash box has 112 bills, only in $5 and $10 denominations, totaling $720. How many of each denomination does Alex have? Well, here again, we're going to seek two unique independent equations, and we have a couple different things. We have a quantity of bills here. He has 112 bills, so that's a quantity of bills. And we have a value of those bills. So tucked in here is going to be our two equations. Well, he's only got $5 and $10 bills, so we will let F equal the number of $5 bills, and we'll let T equal the number of tens. So we know that Alex's 5 plus his tens equals 112 bills. That's our quantity equation here. And then the value, well, we know every $5 bill is worth, well, $5. So $5 times every 5 plus $10 times every 10 equals $720. So we have our value equation right there. So we have our two unique independent equations, our quantity equation, our value equation, and now we will go ahead and solve. I'm going to You could do substitution here. I'm going to do linear combination. I'm going to multiply the top equation, our quantity equation, by -5. So I get -5f minus 5t equals -$560. I add my systems of equations here, and I get 5t, my 5's drop out, 5t equals 160. Divide both sides by 5, and I get t equals 32. So now I know I have 32 $10 bills. And all I need to do from here is solve for the number of 5's. Well, if I know my 5's plus my 10's equals 112, subtract 32 from both sides, and I get f equals 80, so I have 80 $5 bills. So 85's and 32 10's, and sure enough, 85's is $400, 32 10's, 320, 400 plus 320, $720. So that one works out. On to our third word problem. Same kind of thing, different scenario. Ticket costs for the state soccer tournament were $5 for students and $7 for adults. Jenny sold 587 tickets valued at $3,379. How many of each type did Jenny sell? So we have a couple different things here. We've got student tickets and adult tickets. Not a whole lot different than $5 bills and $10 bills. So I'm going to let A equal the number of adult tickets. And I will let S equal the number of student tickets. And we will, again, since we're working with a quantity and a value, we're going to have a quantity equation. Okay, 587 tickets is our quantity of tickets, the number of pieces of paper. And we are also going to have a value equation. So our quantity equation, that's usually the easier one. The adult tickets, the number of adult tickets, plus the number of student tickets equals 587 tickets. And our value, well, every adult ticket is $7, and every student ticket is $5. So that's the value of adult tickets. The value of student tickets equals the total value of tickets, $3,379. Again, we could do substitution here. We could solve this for adult or student, A or S. I'm going to go ahead, though, and do linear combination. I'm going to multiply by -5. So I get -5a minus 5s equals -5 times 587, -2,935. And I will add my system together, and I get 2a equals 444. Divide both sides by 2. So A equals 222. So apparently we have 222 adult tickets. The student tickets, that should be a little easier. Go back to our first equation here. 222 plus the number of student tickets equals 587. Subtract 222 from both sides, and S equals 365 student tickets. So we have 365 student tickets and 222 adult tickets, and we have answered our question. And on to sample problem number 4, an investment problem. Luis invested $5,000, some at 6% interest and the rest at 5% annually. The annual income from the investments is $280. How much is invested at each rate? Well, let's take a look here. We've got some income, and we're investing a whole bunch of money, but only in 2 different things. So once again, actually, even though this is dollars, this is the quantity, this is the amount of money that Luis is investing. And this is our value. Our value of that, or the interest earned, is 280. So from these 2 numbers, we're going to come up with our 2 unique independent equations. And our first one, well, is an investment A and investment B, or the investment at 6%. So we'll let X equal the amount he invests at 6%, and we'll let Y equal the amount that Luis invests at 5%. So we know that X plus Y, those 2 dollar amounts, he invests a total of $5,000. Now our value equation, that's going to be a little different. Since we're investing 6% at 6%, we're earning 6% on every dollar invested at 6%, and we're earning 5% on every dollar invested at 5%, and from that we return $280 in 1 year. So this would be our value or our interest equation, and the first equation is our quantity or amount. I don't like the decimals, so I'm going to go ahead and multiply that whole equation by 100, so I get 6x plus 5y equals 28000. That's $28,000. And then I'm going to go ahead and multiply the entire top equation. I'm going to multiply that by -5. So I get -5x minus 5y equals -$25,000. Okay, I add my system, and the y's will drop out, so I will get x equals $3,000. So then I know he's invested $3,000 at 6%. And if he only invested a total of $5,000, you could probably eyeball that, do that in your head. You can see that he has to invest the other $2,000 at 6%, or pardon me, at 5%. So there we have a few sample problems on using word problems to solve systems of equations, or using systems of equations to solve word problems. As you can see, our goal is to find 2 unique independent equations. Many times it'll be like a quantity equation and a value equation. And then use our skills of either the substitution method or the elimination/linear combination method. Use those skills to answer our question. And that's it for that lesson, and we will see you in class.